Okay, we're going to do in lesson 2-3a, we are going to divide polynomials using long division, and we're going to do it with what's something called synthetic division, which I'm going to show you here in a minute. But long division is, it's just really like regular division that you've done in the past, except with variables. So we're going to take the same steps. So I thought I would do just a kind of a practice one on the side, which would be like if I took 647 and divided it by 3. What would that be? So I would take 3 goes into 6 2 times, and then I would take 2 times 3 to get 6. And then at that point I would subtract, and the 6's would cancel, and I would bring down the 4. And then I would do the process again. 3 goes into 4 once, which is 3. And then I would subtract and get 1, and then I'm going to bring down the 7. And 3 goes into 17 5 times, which is 15. And in this case, when I subtract, I have a remainder of 2. So when you were in the younger grades, we would say 215 remainder 2. And then we looked at, well, what could it be if I didn't put it in remainder 2? I would say 215 and 2/3. I would write it as a fraction. So we'll also have to think about doing that as well. So I'm going to look at doing long division with polynomials. And get rid of that old stuff there. Give us a little more room to work. And the steps are going to be very much the same. I want to write down my dividend, which is the thing that I'm going to divide by, or divide into. And I have x minus 3 out here. The interesting thing is we only look at that very first term when we go through and divide. Another thing that you want to check on is to make sure that your polynomial is all in descending order, and that you're not missing any terms. Like our exponents in this case should go 3, 2, 1, and then 0. If I'm missing, let's say, the 2, then I would want to fill that in with 0x squared in order to kind of hold that place value. So I'm going to do a little division. I would have to just say, well, what would I multiply x by to get 6x cubed? And that would be 6x squared. And then I have to multiply that by both terms in my divisor, which would give me 6x cubed minus 18x squared. And just like we do in regular division, we're going to subtract. And what should happen is your first terms will cancel, and I have negative 25 minus negative 18 is negative 7x squared. And then I want to bring down my 18x, because however many terms are in my divisor, I have 2 terms here, x and minus 3, or negative 3. I have to have that same number that I'm working with each time. So I needed to make sure I had 2 terms. Then I'm going to say, start all over again and say, well, what would I multiply x by to get negative 7x squared? And that's going to be negative 7x, and you multiply by each term again. So that was going to be negative 7x squared plus 21x. And then subtract. And you get your negative x squareds will cancel, and I'm going to get negative 3x. And again, I have to have 2 terms to work with, so I want to bring down that 9. And then what would I multiply x by to get negative x cubed? Or negative 3x, sorry. Would be negative 3. And I have to distribute again or multiply by everything, would be negative x cubed plus 9. And when you subtract, this time, both terms will cancel and you end up with a remainder of 0. So that means I'm done, which means it was completely factorable. And that's my answer. What this tells me is that the polynomial that I started with has at least one factor of x minus 3. So what I divided by divided into it evenly, and so it gives me a factor of x minus 3. I'm going to leave the next one 1a for you guys to do, and I'll go down to here to example 3 when we're going to divide by a bigger polynomial. The steps are still going to be the same. So I'm going to write down my dividend, which is 2x to the 4th minus 4x cubed plus 13x squared plus 3x minus 11. And I'll notice that it's in descending order and I'm not missing any terms. And then I want to divide all. Alright, anyway, I'm going to try to divide this, and that I'm going to multiply negative 2x by, not sure where I get the negative 2x plus 7. Let's back this up. I guess it's x squared minus 2x plus 7. There we go. That looks better. So when I divide this, I want to say, what can I multiply x squared by to get 2x to the 4th? And that's going to be 2x to the 2nd. And then I have to distribute everything, 2x to the 2nd times everything in my divisor. That's going to give me 2x to the 4th minus 4x cubed plus 14x squared. So I had 3 terms. I'm going to have 3 terms when I subtract here. Well, my first term is going to cancel because I kind of set that up to do that. My negative 4x cubed are going to cancel. And then I have negative 1x squared. I have 3 terms in my divisor, so I need 3 terms when I divide, which means I'm going to have to bring down the 3x and the 11 so that I'll have 3 terms to work with. And then I want to say, well, what can I multiply negative x squared by, or x squared by to get negative x? And that's negative 1, which is going to give me negative x squared plus 2x minus 7. And I'm going to subtract. My first terms will cancel. And then I have 3x minus 2x is x. And negative 11 minus 7 is going to be negative 4. So I ran out of numbers to bring down, so that means that I have a remainder here. This guy. So how I write this as a remainder, I'm going to keep my quotient, but it's going to have a remainder with it. And so it's going to be 2x squared minus 1 as my quotient. And then I'm going to treat this like it's a fraction. And I'm going to have x minus 4 over my divisor, which is x squared minus 2x plus 7. But I don't want to just put it there. I'm going to add that fraction to it. And then that is my final answer. What that means is that my divisor is not actually a factor of my original polynomial. Okay, the next thing we're going to look at is this concept of synthetic division. And what you want to do is, and we're going to look at the example that we have here at the top of the page, is to take the polynomial and you're going to write down just the coefficients. So you can see we have the 6, we have the -25, the 18, and the 9. And then your divisor, which in this case is x minus 3, we're not actually going to divide by x minus 3. You're going to take that x minus 3, or whatever binomial you have, and you're going to set it equal to 0. And then you're going to solve for x, and you're going to get x equals 3. That is what you're going to synthetically divide by. And you can see that we actually have it over here. So the first rule is that you bring the first coefficient down, which is the 6. And so they brought it down. And then you're going to take the 3 and the 6, and you're going to multiply them together, and the product is 18. And the 18 is going to go in the second column. The big difference here is instead of regular division where you would subtract, we're going to add the columns together. And then when you do that, and we'll continue that process, -25 plus 18 is -7. And then you multiply, you start all over again, and you say, well, 3 times -7 is -21, and then you add, and so forth. What happened here is that I usually put a bar right before the last term, because that last one is going to represent a remainder. And in this case, the remainder is 0, which means that x minus 3, which would have been the original divisor, is a factor. And so how I do this then to write my answer would be to say, well, that's going to be 6x squared, which happens to be 1 less than the x cubed that it started with. And then this is going to be -7x and -3x to the 0. Okay, so let's do it for real this time. We're going to do some synthetic division. We're going to start by taking the divisor, and we're going to set it equal to 0. So x plus 2 equals 0. And then solve. So I get x equals -2. That's what we're going to use in our synthetic division. That's what we're going to divide by. And then we're going to, what I like to do is put columns for each of my terms. Now if I look at this, I see that I'm in descending order, but I'm actually missing the x cubed term. So I want to account for that when I do my synthetic division. So I've got x to the 4th. I need an x cubed column. Oh, try that again. X to the 4th, x cubed, x squared, and x, and then what I could call a constant column. I can almost write that 3 there. Okay, and then so the coefficients for those were 2, and there wasn't an x cubed, so I'm going to put a 0 there, and that gives us something in the place value, but nothing of value itself. And then I have -x squared, or -5x squared, a 5x, and then my constant was -2, and I'm going to do my synthetic division with -2. So you want to bring down the 2, and that's always the first thing. You always bring that first coefficient down, and then we're going to multiply the -2 and the 2, and the product is going to go under the 0, which is -4. and then I want to add my columns. So that's going to be -4, and then I'm going to do the process again. I'm going to take my -2 that I'm dividing by times -4 is -8, or excuse me, +8. And I'm going to add and get 3. And then I want to take -2 times 3, which is -6. Add those. Gives me a -1. And -2 times -1 is 2. And when I add, that last column is where I'm going to have a remainder, if there is one, is 0 in this case. So it works out perfectly. What happens then is that in my x to the 4th column, my quotient is going to have 1 less power than that. So this would actually end up being 2x cubed in my quotient minus 4x squared plus 3x minus 1. And there's my answer, and there was no remainder this time. Okay, and then on the last page there, I'm giving you one to try out and do the synthetic division there on your own. I will get you started a little bit because this one kind of looks funny. It's not really that hard. We still take that divisor, and that's the 2x minus 3. I'm going to set it equal to 0. And then add 3. So that's 2x equals 3. And then x equals 3/2. So this time I'm going to divide by 3/2. You could also write it as a decimal and say 1.5. But that's what I'm going to divide by. Okay, and for that first half of the lesson, you have on page 115, numbers 2 through 28, the evens to work on.